This is me and my affiliation. In this video, I thought of taking up a problem on mesh analysis again. But the difference is that in this network, I'm trying to take up a dependent source. Now, how to deal with networks having dependent sources is the topic of today. I have made a video on dependent sources also. You can have a look at them if you are not clear about what do we mean by dependent sources. Okay, so in this network, the problem says determine I1 and I2. The problem is to determine I1 and I2. How do we do such a problem? Now, sometimes if you see dependent sources, you feel little, you find it difficult. But let me tell you, there is absolutely no difficulty in dealing with dependent sources. So in this network, we can see that this 2-volt source, this source is an independent source. Whereas the other source, that is this particular Vx by 4, is a current source. And this current source, as a symbol itself suggests that it is a dependent source. Dependent sources are represented by rhombuses or diamond-shaped figures. And this is a current source because one can see an arrow within it. So it is a voltage-dependent current source because the magnitude of this current source is Vx by 4, where Vx is the potential difference across this 2 ohm resistor. Alright, so that is how we have to interpret the dependent sources. Now, how to write the equations for these dependent sources? For this particular network. As we can see, we have two unknowns, I1 and I2. So, we would be requiring two equations to solve for I1 and I2. Additionally, you require one more equation to find out what is this Vx. So, collectively, in all, we would be requiring three equations. And solving three equations, we would be able to determine I1 and I2. So, how to do the equations, how to write the equations? It is as simple as any other network. We write simple KVL equations, connect for the two meshes that we have, and additionally we can write one more equation in terms of Vx. So let's see how we go about this problem. All right, let's see. For the mesh 1, we can write an equation, but then here if we take this as mesh 1 and write an equation for the mesh 1, we may need to know the potential difference across this current source. We may need to define one more variable, which is not advisable. It will unnecessarily increase the number of variables. So what is done is, we try to take what we call as a super mesh. This is what we call as a super mesh. I will try to show the super mesh this way. This is the super mesh we have. I'll put a dotted line, maybe in a different color, to identify the super mesh. So this is going to be my super mesh. So I can write a KVL equation for this loop, or in other words, this pink line would be called a super mesh. Okay, so we are trying to bypass the source and form an equation. So we will write an equation for this mesh. We will see what is it we get. If we start from this point, so I normally start from the top left corner whenever I write mesh equations. That is my convention. I try to do it that way. So I'm trying to start from this top left corner. This corner, 1.4 ohm resistor. As you can see, the pointer, yellow pointer. So we will see, right? So what is the potential difference across 4 ohms? It is 4 times I1. So the current is flowing from left to right. So there is a drop in potential from left to right. And the magnitude of the drop is 4 times I1. That is R into I. And it is positive. I'm taking drops to be positive. This has been my convention. All right. So now I have come to this node. Then I have to go through 6 ohm resistor. So through 6 ohm resistor, I2 current is flowing again from left to right. So it is going to be a drop in potential from left to right. So it is going to be plus 6 times I2. That is the drop. Plus, you have got 2 ohm resistor. There again I2 is flowing. Plus 2 into I2. I have come back to the source, which is equal to 20 volt. This is 20 volt. I am sorry, the problem is this is not 2 volt. Instead, it is 20 volt. One has to be a little careful with the data. Anyway, okay, so I'm able to get one equation. One equation is in I1 and I2. All right, so you require few more equations, right? Two more equations to write. Okay, so the other equation that we can write is, in terms of I1 and I2, the current that is flowing in the in this branch through the current source, that is Vx by 4, can be expressed in terms of I1 and I2. So I can conveniently write I2 minus I1 is the current through the dependent source, that is Vx by 4. So I'm able to get second equation. Okay, this isn't sufficient because you have one more variable Vx. So what is Vx? Vx is the potential difference that is coming across 2 ohms. So whatever is the potential difference across 2 ohms that is getting generated when I2 is flowing through 2 ohms is what we have called as Vx. So I can conveniently write one more equation. What is my Vx now? Vx is 2 times I2. This is my third equation. Now my problem is done. That's all I would require. So we need to write 3 independent equations because we have 3 unknowns. Unlike any other circuit of this nature, additional to the 2 mesh currents, you have one more unknown, that is the magnitude of the dependent source. So with this, the problem gets solved. Let us try to substitute one in terms of another and try to obtain the things. Okay, so I will try to substitute and solve. What is Vx equal to 2I2? I'll put this is now, the rest is very simple. I'm trying to substitute 3 in 2. Okay, so I'll putting equation 3 in 2. Whichever way, all you have to do is to solve for I1 and I2. Okay, so that comes out to be I2 minus I1 equal to, for Vx, I'm substituting 2I2 divided by 2. So my 2 and 2 would get cancelled off. All right, so I've got Vx by 4, right? So this is 2I2 by 4. This is not 2. This is Vx by 4. So I've got this to be 2. Okay. So I2 by 2 I2 minus I1 is equal to I2 by 2. Or this would be, if I can take it on that side, I will get I2 by 2 minus I1 equal to 0. Okay, this is one equation. This is my equation 4. All right, so I can write the same equation. You can use equation, what is that, equation 2 and equation 4 and solve. Okay, we can solve using these 2 equations. We can easily obtain rather equation 1. What will happen to equation 1? Equation 1 can be written as, I will divide everything by 4. So I will get it as I1 plus 8I2 divided by 4 is 2I2 and 20 divided by 4 is 5. This is one equation I have. And this is my equation 1 modified, right? This is equation 1 modified. And I will take up the equation 4. What is equation 4? Equation 4 is minus I1 plus I2 by 2 equal to 0. Okay, I will add the 2 equations. So I will get this to be equal to 5I2 by, if I can adding the 2 equations, what is it I get? So I will get 2.5, right? 2.5 is 5 by 2. It's 5 by 2, I2 equal to 5. Cancelling off 5 and 5 on either side, I2 equal to 2. I'll get I2 equal to 2 ampere. And on substitution in equation 4, so I will get I1 equal to 1 ampere. That would complete the problem. Okay, so it is a simple problem. Problems of this nature are little simple, but you have to be little careful in dealing with the variables, and of course one has to be careful with substitution and simplification. One has to be little cautious about all these things. Okay, this would complete the problem. So let's have a quick recap of what we have done. Okay, so we in this problem we could see a a dependent source whose magnitude is Vx by 4. Vx is nothing but the potential difference across 2 ohm resistor. So while forming the mesh equations or loop equations, we try to avoid this current source. We try to take a route or a loop in such a manner that this dependent source gets avoided. Okay, this is an example this particular example is convenient to that approach. Okay, so we've defined a loop in this manner. In this manner, we have defined a loop and we wrote the equation for that loop, which is our equation 1. Okay, so that equation 1 has got I1 and I2 as variables, 4I1 plus 8I2 equal to 20. Okay, which further gets modified and we are able to write this equation. Then the other equation that we have is the difference in the mesh currents I1 and I2 would result in the current through the source, that is the dependent source. So we are able to get one more equation. So we have one more variable Vx. We have to have an equation for Vx. It is simple. Vx, potential difference across 2 ohm, is the current through 2 ohm multiplied by 2 ohm itself, that is 2I2 is Vx. So we are able to get 3 equations and 3 unknowns we can solve. Okay, it is as simple as that. Now what is Vx equal to? What is the voltage Vx? So Vx voltage, if I have to evaluate, it is going to be 4 volt. Okay, this is 4 volt and this is going to be 1 ampere current source. Alright, so substituting, one can always verify it to be true. Okay, so I2 minus I1 rather is we have written, right, Vx by 4. That also gets verified using these values. I'll take up a couple of more problems on this type of networks so that the understanding becomes simple. We will try to work out some problems, network analysis problems on node voltage technique having dependent sources. I suppose I'll stop this video here. Let it be a small video so that you will not feel bored to watch the video. Thank you so much for watching.